Hello, everyone, and thanks for joining us here at NASA JPL's Instagram live page. I'm Marina Jurica, and I am here live in Southern California at NASA's Jet Propulsion Laboratory, and we are going to do an exciting chat today about the SWOT satellite. And the SWOT satellite just launched from Vandenberg Space Force Base last month, and the SWOT mission is a joint mission between NASA and CNES, which is the French space agency. And SWOT is going to be able to track water on more than 90% of the Earth's surface. And we are super excited to talk to you about this satellite today. In just a few moments, I'm going to bring in Marc Simard, who is a senior scientist here at JPL, and he has seen firsthand how climate change has really affected the water bodies across the planet. And he's going to tell us a little bit about how SWOT is going to be able to track and monitor those changes from climate change. So bear with me here just one moment while I bring Marc into the conversation from our sister channel, NASA Climate Change. And there we in middle of December successfully from Vandenberg Space Force Base, and now it is deploying its solar arrays and different instruments and getting testing done, and we're super excited for that data to come down. Hello, Marc.
Hello, Marina. How are you doing?
Great. Thank you so much for joining us here today.
Thank you.
So tell us a little bit about where you are and what's behind you.
So currently I'm in the Von Karman Auditorium at the Jet Propulsion Laboratory, Pasadena, California, on our beautiful planet Earth. And I'm standing in front of a 1/3 model of SWOT, the Surface Water and Ocean Topography. So the actual satellite is 3 times as big as this one. So this is pretty small. Actually, these antennas that you see here, well, you see part of it only, but they are 10 meters wide, so 30 feet wide.
Now, SWOT has already launched into orbit, as I mentioned before you joined us, Marc, and the real work is just getting started. So tell us what SWOT stands for and what your part of the mission is.
Okay, SWOT is an acronym, so Surface Water and Ocean Topography. So as its name says, it's going to measure topography. So topography is just the height, right? So it's the height of the oceans, the heights of the lakes, and the rivers. And it will make that with unprecedented accuracy and with very, very wide spatial coverage.
And what is your part of the mission, Marc?
So my part of the mission, so I'm a principal investigator within the SWOT science team. So my component is actually the end in surface water and ocean topography, because I'm interested in coastal areas. So coastal areas are very interesting because it's basically where the interaction of the rivers and the ocean tides come into play. So you have the fresh water coming in and the salt water coming in and out and pushing back and forth that fresh water from the river. It's like you have an eternal dance between the river and the ocean. It's beautiful. There's a lot of processes happening there. It's very, very dynamic. It's also very productive. This is where you find mangrove ecosystems, marshes, salt marshes, even freshwater marshes like in Louisiana. And this is where a lot of life happens. And this life and everything that is sustains, whether it's fish, crustacean, also sustain the livelihood of millions of people. So these are really, really important areas, not only scientifically, but also for the people.
That's right. The wetlands are like a barrier. A lot of folks here at home don't know how protective these places are. And I know when you and I were in Louisiana together, we saw so much of this. It's not only for infrastructure and for people, but like you said, who inhabits the wetlands. So tell us a little bit about the benefits you are seeing from conservation in that area, but also the loss of the wetlands, which is so critical to contain.
So because we have long time series of data, say from the Landsat archive, for example, we can go back all the way to the 70s, 80s. We've seen a lot of land loss in these coastal wetlands, whether they're marshes or mangrove forests. It can be due to, it's a combination of climate change and also human impact, of course. So the role of human cannot be neglected, and the benefits of these wetlands to man is also not to be neglected. It's very important. So these ecosystems protect us against the impact of climate change, whether it's the fact that sea level rises or the intensity or the intensifying impact of hurricanes, for example, and storms. They act as a buffer that protect us against these impacts. And we've seen that in several areas around the world, whether it's in Southeast Asia or even Louisiana, the Everglades National Park. So these ecosystems are really important and they protect us. So I think it's also our duty to protect these ecosystems. And I think that's one of the things SWOT will help us do, is to better understand how these ecosystems can be helped to continue and protect us. Because the interaction between these ecosystems and the water is critical. They thrive in these regions where you have the mix of fresh water and salt water. So I think SWOT here will be really, really helpful.
Yes, it's hope for the future, which is great, Marc. So speaking about dynamic environments and unusual weather, here in California, we have tapped into an atmospheric river, and we've been seeing some very unusual weather coming in from the Pacific Ocean. Now, we are getting as much rain as we usually see in an entire season in a week. Tell us how SWOT is going to be able to show us atmospheric rivers in the future.
Yes, so SWOT will not see those atmospheric rivers directly. However, it will be able to observe the impact it has. Once the water hits the ground, it goes into the rivers and the lakes. This is when SWOT will be able to help us. It will be able to help us understand the impact of those atmospheric rivers on the water level in rivers and lakes around the world, everywhere. And thanks to the technology that's on board, so it's based on radar, right? So radar helps us see through clouds. We can actually see through clouds. So we can make measurements during the storm, of course, if the platform is above the storm, so it can be somewhere else in the world, right? So it doesn't cover the entire Earth instantaneously. It goes around the Earth. So we can make measurements during the storm. And even after, if there's some clouds remaining, we can still make measurements thanks to that radar technology. We can make measurements of the impact of that atmospheric river on the water level in the rivers and the lakes. So with SWOT, we can only see water level where you have the rivers and the lakes. But with NISAR in 2024, which will be launched, we can combine the data from SWOT and NISAR to also look at the impact of flooding across the land and also better understand the impact of these atmospheric rivers on our landscapes.
It takes a village, even if it's a village of satellites, right, Marc?
Yes. Yes.
Now, what sets SWOT apart also, like you mentioned, is the fact that it can see through clouds. A lot of its predecessors weren't able to do that before. So that is a really great break in technology. Now, is there anything in your background that uniquely has prepared you for this mission? I know you love to travel and that you've seen firsthand these effects of climate change on deltas in Louisiana and across the world. So tell us a little bit about that.
Okay, so I've been studying mangrove ecosystems and marshes for the last few decades using radar interferometry, so technology very similar to that of SWOT. I was looking at vegetation structure, for example, so the height of trees and how they grow. So going around the world and understanding the interaction of these ecosystems with the hydrology is critical. So it's really important to understand how these ecosystems work together with water and also with people. So from my background in radar remote sensing and also my understanding and my experience in these coastal ecosystems, I really think that here with SWOT, we're covering a missing link. And I'm really hopeful on what SWOT can bring us in helping our understanding of these ecosystems, which are extremely dynamic.
Wonderful. Thanks so much, Marc. Now, we've got a lot of questions over the last couple of weeks from different social media platforms, and I think you will be able to answer a lot of them. Are you up for that?
I am.
All right.
Go for it.
Our first question comes from Clavy on Twitter, and they ask, how will SWOT data be shared with institutions and the general public?
Okay, so SWOT data, first of all, will be free to all starting in the fall of this year. So whether you're a high school student working on a science fair, a grad student working on a thesis, or a professional researcher, engineer, the data is all yours. It's yours to use. SWOT will provide data everywhere in the world. So whether you're interested in the Niger Delta, in Bangladesh, the Everglades, the Amazon River, or even coastal New York, the data is there for you to use. And for us, it's not only to make sure that you can use the data, we really want you to use the data. We want to make something that is useful. All the data that's collected by SWOT and other NASA satellites are free and available to all.
And that's what's so incredible. I hope everyone is going to really take advantage of that, Marc. And if you're just joining us, we're here with senior scientist Marc Simard at NASA's Jet Propulsion Laboratory talking about the latest launched Earth mission, SWOT, which will be tracking the Earth's water. So going on to our next social media question comes from Shakar on YouTube. What exactly is the SWOT mission doing for Earth, and how will it help us better understand climate change?
Okay, so climate change, you may have heard of the carbon cycle. So the carbon, when it's in the atmosphere, is a greenhouse gas. It can be stored in forests or the ocean. So there's a missing link here in our understanding of that carbon cycle. And I believe this missing link is not between, we know about the link between the ocean and the atmosphere and the forest. We still, it's not super accurate, but we're working on it. But the big missing link, to my point of view, is the transport of carbon from the land to the ocean. And that transport is through rivers and estuaries and river deltas. And this is SWOT. This is where SWOT can really help us. Since SWOT will give us estimates of the flux of water from land to sea, and if we know how much carbon there is in that water, we can also know about the export of carbon from the land to the sea. And that, I think this is where the big breakthrough will be in terms of climate change, understanding climate change. But I think, in my opinion, the big thing for SWOT will mainly be about the impact of climate change. So we do have shifting precipitation patterns around the globe. We're seeing that in California right now. So sometimes we'll have places where we used to have water, a lot of rain. Maybe there won't be so much rain in the future. Some other places where they didn't have much rain will have more rain. There's a big shift in these precipitation patterns, and SWOT will really help us measure what's happening with that shift, what the impact of that shift is on the transport of water across the land. And because of the measurements that it will provide on these shifting patterns and also on the current ones, it will help us calibrate hydrological models for the surface. So once we have these accurate models, because they'll be accurate, because now we have something watching over us to make sure that these models are good, we can use these models to forecast where water will be transported and where it will not be transported, and how much of that water is being transported. So I think,
in a lot of cases,
it's about the impact.
Right. And in a lot of cases, we haven't had that information before, especially globally. And so that's really what sets SWOT apart.
Yes.
All right, on to the next question, a great one from social, and I know you have a lot to do with this. So is there a process that goes into validating and confirming the data before it is released publicly?
Yes, definitely. So we have several teams within the SWOT science team and the SWOT project going around the world across North America, making in situ measurements. So we're basically installing water level gauges in several places around the world. Some of those places will also be collecting LiDAR measurements from aircrafts and air SWOT measurement. Air SWOT is an instrument that simulates SWOT, but it's on an aircraft and we know it works. So we can check and make sure that SWOT data is accurate and that it can be distributed with great accuracy. So we have several campaigns going on. My team, we're going into 3 different regions and we're focusing on estuaries. So during the CalVal, the calibration and validation phase of SWOT, which is from March to June, SWOT will be overpassing just several areas around the world, very few estuaries and deltas. So we picked 3. We picked the Guayas estuary in Ecuador, where we'll be installing a dozen of water level gauges, just to make sure, again, that SWOT is making actual and accurate measurements. We're also being deployed to Gabon in the Como estuary. So again, there we'll be placing a few water level gauges around to compare with SWOT. And then in April, May, we'll be going to the St. Lawrence River to install gauges, but the experiment there is a lot more intense, let's say. We have LiDARs flying, so aircraft with laser altimeters, and we also have what I mentioned before, the air SWOT, which is a radar interferometer, just like SWOT, but installed on an aircraft. And we know it worked because we used it in the Mississippi River Delta for a Delta X experiment that occurred in 2020. So 2021. So we'll be deploying these instruments everywhere, making sure that SWOT is giving you and providing you accurate measurements. So think of it as quality control.
That's right. So you guys are going all over the world, many different groups of you, to make sure that you're validating all the SWOT data that's coming down to make sure that it's accurate. And one of those places you're going to is near your hometown.
Yes, indeed. It's pretty fortunate. I'm pretty happy about that. That's fun.
And tell us a little bit about where you're from.
Yeah, so I'm from a town called Arvida, which is 2 hours north of Quebec City, along a river called Saguenay. That Saguenay is actually an estuary that throws itself into the St. Lawrence estuary. So SWOT will be covering during its calibration and validation phase those 2 estuaries, so the St. Lawrence estuary and the Saguenay estuary. So it will be a pleasure to be there and finally understand things that are close to home, which I still don't really understand.
And hopefully in that area, you won't encounter what we did in Louisiana, Marc. I'll never forget the mom alligator near that river gauge for sure.
Yeah, there's no alligator there yet. So
that's a good thing.
The water is just very cold, so I don't think we'll be encountering anything in the water.
Just in Louisiana.
Yes.
And a point I wanted to make sure people understand that are joining us today is the wetlands are such a sacred and really beautiful place, and the conservation and protection that you're doing in Louisiana has shown improvement. So I really wanted to show folks that there is a positivity that's coming out of the preservation and the steps you're taking to make sure that they're here for many generations to come.
Yeah, indeed. So I mentioned earlier the Landsat archive. So we see a lot of land loss around the world, including in the Mississippi River Delta. But we also witnessed, we're using these archives of data, some places where we're gaining land. So if you look at the Atchafalaya Basin, which includes, it's a coastal basin where the Atchafalaya River and the Wax Lake outlet go into the Gulf of Mexico. This place is actually building land. We're talking about all the impact of climate change and people and so on, but some areas are building land. So there is hope. So if we understand how nature can build resilience to climate change, and we can maybe try to replicate that in other places around the world. So with this Delta X mission, which is airborne, which I mentioned, we're trying to do that. But for the Mississippi River Delta, we cannot send airplanes everywhere in the world. So SWOT will do that for us. So we'll be able to do what we're trying to do in the Mississippi River Delta using SWOT to other places. So we can go around the world trying to better understand the interaction and how we can build deltas.
From space, from air, and then boots on the ground on land.
Indeed.
Now,
or in the boat.
Yes. Now, I know that you speak 5 languages, Marc, and this is an international mission, SWOT. So are there any closing remarks that you might want to say in each of those languages?
So I would say 4.2 languages. My Portuguese is more like Portuñol. So, okay, so just maybe just summarize in those languages. El agua sigue un ciclo. L'eau s'évapore des lacs, des rivières et des océans, des sols, et retombe sous forme de pluie et de neige qui s'écoule dans les rivières, supportant bon, la vie. On en fait même de l'électricité. Es como el agua de verdad es la esencia de la naturaleza y también una fuente de vida. And now, what language is that? Okay, the next one. So, I have to switch here. So, adesso che possiamo mandare strumenti potenti come SWOT nello spazio, possiamo osservare dove l'acqua, quanta acqua c'è dappertutto e capire l'interazione fra ecosistemi e l'acqua. È molto importante capire questo ciclo. Now the last one, which is my point 2. Eu vi as costas e mangués do Brasil e Moçambique. Vi sua importância para a gente que moram lá. So yeah, that's it. That's my Portuguese.
Wonderful. Wonderful. And I'll add a little bit of Croatian here to the mix too, since that's my other language. Mi svi trebamo voda na ovaj svijet. We all need water on our planet Earth. So thank you so much for joining us here today, Marc. We learned so much, and it was a real pleasure talking with you.
All right. Thank you very much. See you. Bye, everyone.
And thank you so much to all of our viewers for joining us today. Now, if you want to learn a little bit more about the SWOT mission, you can join us and follow us on our 2 social channels that were featured here today, at NASA JPL and at NASA Climate Change. And 2 weeks from today, get excited, we're going to be talking to one of SWOT's engineers, Christine Jabara, and we're going to go into more depth about what sets SWOT apart on the engineering aspect. And always remember, at NASA Earth Science, your home is our mission. Go SWOT and have a great day.
Go SWOT.